Some of the DC sources are cell, battery and etc. So these are some of the examples for direct current sources. So there is a lot of uses from this AC because even in our houses we use alternating current which varies like a sine function with respect to time. The instantaneous value of EMF or instantaneous EMF is calculated by the expression E is equal to E naught sine omega t. Hello everyone, welcome to session 1 of the chapter called Alternating Current. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear children, it is very important to know about the concepts of alternating current as the uses of alternating current in our daily life is vast. So, let us start studying about alternating current by just having the introduction. So, alternating current is shortly even called as AC. AC stands for alternating current. So, there is another type of current called as DC, which means the direct current. So, from a DC source, we get the direct current. What is the meaning of direct current? What is the basic difference between this AC and DC? So, direct current will not vary with respect to time, whereas in case of alternating current, the current varies with time. That is why the name, since it varies with time, we call it as alternating current. So where do we get this direct current from? From direct current sources. So we get direct current which does not change its direction with respect to time. Some of the DC sources are cell, battery and etc. So these are some of the examples for direct current sources. In case of AC circuits, which means alternating current circuits, AC source is used. We do not use a DC source, we use AC source. So from this AC source, we get alternating current which changes its direction with respect to time. We can also get the alternating voltage which changes its direction periodically with respect to time. So the examples for the sources of alternating current, AC generator. It is even very important to know about the circuit symbol for AC as well as DC, which you might have all observed in your laboratories. The symbol on the sources of AC and DC. So, alternating current is represented by a symbol of sinusoidal wave, which means it says that the alternating current is changing its direction with respect to time. And DC, which is represented by this symbol. So, this is the basic difference between the symbolic representation or electronic circuit symbols for AC and DC. Since the AC changes periodically with respect to time, we get sinusoidal waves. Since we get sinusoidal waves in case of AC, the waveform symbol is used as electronic circuit symbol for AC circuits. So there is a lot of uses from this AC because even in our houses we use alternating current which varies like a sine function with respect to time. What are the main advantages or what are the main reasons to prefer AC over DC? We need to understand. So AC voltage can be easily, effectively and efficiently it can be converted from higher values to lower values and vice versa by the help of transformers, which means we can use whatever the amount of voltage we require for our daily life with the help of transformers by increasing or decreasing its value. So it can be easily varied with the help of transformers, and that is one of the reasons to prefer AC instead of DC. So energy can be transmitted over long distance economically. It is even the cost effective. So economical parameters will also matters in transferring the voltages from one place to another place. So the energy can be transmitted over long distances even it is economically friendly. And today most of the electrical devices we use requires AC voltages. So these are some of the important reasons for preferring AC over DC. So to understand completely about the alternating current or AC voltage, it is very important to know about certain parameters and we will call it as AC parameters. So let us start with instantaneous value. So what is the meaning of instantaneous value? The name itself says instantaneous, which means the values of alternating current or the alternating voltage at that particular instant of time or at a given instant of time. The instantaneous value of EMF or instantaneous EMF is calculated by the expression E is equal to E naught sine omega t. As well as the instantaneous voltage, we have an expression V is equal to Vm sine omega t, where Vm is nothing but the peak voltage. I'll tell you what peak voltage is. And next is instantaneous current. Current is denoted by a letter I, which is equal to Im sine omega t. So the next parameter to understand is a peak voltage. The name itself refers. Peak voltage means the maximum value or the amplitude of AC. So this value is called as peak value of voltage or peak value of current. Peak value of voltage is denoted by Vm and peak value of current is denoted by Im. So it is nothing but the maximum value attained by AC current or voltage during a cycle. So if it is varying current, then this is a peak current. So if it is varying voltage, then it is a peak voltage, which is denoted by Im and Vm respectively. The next important parameter is time period of AC current. So the time required for one complete cycle of AC is called as time period. What is the time required for one complete cycle of AC? That gives us the concept of time period. So going forward, we have to know about the frequency of alternating current. We all know about the general definitions of time period and frequency. So frequency for number of cycles can be defined as the number of cycles set up in 1 second. Similarly, frequency of alternating current or voltage is defined as number of complete cycles in 1 second. Say for example, if I have 1 second, what are the number of complete cycles that takes place in 1 second gives us the value of the frequency of AC for both alternating current as well as alternating voltage. So the next important parameter in case of AC is the mean value or the average value. So the definition for mean or average value stands quite different to understand, because mean or average, generally we say it is nothing but the total divided by the number of trials or the number of values we have. So here in case of AC, the mean value or the average value is defined as the instantaneous value of an alternating current or voltage measured over a half cycle. So the half cycle is this one. Since it is the full cycle, this is called as half cycle. It is nothing but the instantaneous value or the average value can only be measured to the half cycle. So the formula to find the instantaneous current is I average. I stands for current and AV stands for average. I average is equal to 2 divided by pi into Im, where Im is the peak value of current, or we can call it as peak current, or we can also call it as maximum current. Similarly, for a mean voltage or average voltage, the expression is 2 divided by pi into Vm, where Vm is the peak voltage. This is how we can calculate the mean or the average current for an AC or the mean value of voltage. So the next AC parameter to understand is root mean square value, which is shortly called as RMS value. So RMS value for current as well as voltage can be calculated. So this can be calculated by taking the ratio of peak value divided by root 2. So in case of current, it is Im divided by root 2, because Im is the peak value of current. In case of voltage, it is Vm divided by root 2, because Vm is the peak value of voltage. So it is one of the important formula to remember for IRMS as well as for VRMS. For IRMS it is Im by root 2 and VRMS it is Vm divided by root 2. So the next parameter is phase of an AC. Phase is denoted by a letter called phi. So what is phase? It is nothing but the fraction of time period that has elapsed after the voltage or current has passed through a reference value. Say for example, I have two waveforms here. One is for voltage and current. This is the reference value. So what is the time period or the fraction of time period that has elapsed after voltage or current passes through this reference point? Say for example, now they are in phase with each other. In other cases, the current will go through this point like this, which creates a difference between the reference points, and we will call it as phase. So phase is basically a fraction of time period, of the difference of time period between the voltage and the current value. Generally it is called as phase. So it is given by the letter phi. So very interesting and important concept to understand in the study of alternating current is phasors. We have come across the word called phase, but phasors are new to us. So what is the meaning of phasor? A phasor is a rotating vector. It is basically a vector which is nothing but the representation of AC current or voltage. The AC voltage and current are treated as rotating vectors which rotates in anti-clockwise direction like this, which rotates in anti-clockwise direction with an angular speed called omega. Since it is rotating in anti-clockwise direction, it has got some speed. So the angular speed, the angle will changes from one point to another point. The angular speed is denoted by omega. So the length of the vector gives the measure of peak value of AC voltage or current. So this is called as the length of vector, which gives the measure of peak value of voltage or current. The angle between the voltage vector and the current vector gives the phase difference between them. So if we plot two phasors, one is for voltage and current, the angle between two vectors. Say for example, I have one more vector here for another voltage or current value. So the angle between those two vectors gives us the phase difference between voltage and current. And the projection of the phasor to the vertical axis always represents the instantaneous value of the current or voltage. So we will understand about all these points while writing the phasor diagram, which we are going to study in the upcoming slides. Now we have come to know about what are the AC parameters, what's the basic difference between the alternating current and the direct current. Now let us understand what if an AC voltage is applied to a pure resistive circuits. We know that AC sources are used for circuits. So for a pure resistive circuit, which means it contains only the resistor, what happens if the AC voltage is applied? Which means we are going to find the expression for current when AC source or when AC voltage is applied to a pure resistive circuit. For this, we have considered a resistor and an AC source. This is a very simple circuit diagram to understand. It's a pure resistive circuit where we do not have any other components except resistor. So now in this circuit diagram, R is the resistance of the resistor which is connected to a AC source. Now as soon as the AC source is connected to resistance, there exists a potential difference. So the alternating potential difference, and it is given by V is equal to Vm sin omega t, because we have already learnt the value of instantaneous voltage. As soon as there is a connection between the resistor and a source, there exists an instantaneous voltage, and the expression for it is given by Vm sin omega t. What is Vm here? It's the peak value of voltage, and omega is the angular frequency. Now there is a resistance, there is a voltage, which means there exists a current in the circuit, and it is given by the Ohm's law. So what Ohm's law says? It is V is equal to I into R. So from this we can write I is equal to V divided by R. So from that we get the expression for current, that is V divided by R, and let it be my equation 2. Now I have got the value for I. In the first equation we have Vm sin omega t. So we have these two equations. From equation 1 and 2, I can substitute the equation 1 in equation 2. So we get I is equal to, in the place of V, Vm sin omega t divided by R. So what is this Vm divided by R? It can be replaced by a term called Im, where Im is nothing but the peak current, or we can say that the current amplitude. So Im is equal to Vm divided by R. So this I is equal to Im sin omega t be my third equation. So now look at this carefully. I is equal to Im sin omega t, and here we have an equation for voltage, that is Vm sin omega t. So comparing these two equations, they are similar to each other, which means we have got two equations. The first one is Vm sin omega t and next one is Im sin omega t. There is no phase difference between these two, and this is for voltage and this is for current. So since there is no phase difference between these two equations, we can observe, so we can say that the voltage and current are in phase with each other when the AC source is applied to a pure resistive circuit. So now we have to represent this in phasor diagram. So for that, let us consider the graph of voltage and current versus omega t. So this is the graphical representation or the signal of voltage, and the green line what you can see here is the current waveform. So now they are varying with respect to time, and they are having an angular speed of omega. Along x-axis it should be omega t, along y-axis it should be voltage or current. Now projecting this here, so we can write the phasor diagram. As we have learnt already, the vector gives the value of peak value of voltage and current. Since this is voltage signal, the vector in the red line gives us the peak value of voltage and the vector in the green line gives the peak value of current. Why there is no difference between them? Why they are overlapped with each other? Because there is no phase difference in these two equations. So hence they are overlapped. So now the projection along the vertical axis gives the instantaneous value is what we have studied in the previous slide. So the green line gives the instantaneous value of current because here it is the projection of this peak. And next, Vm sin omega t is the instantaneous value of the voltage, because here it is projected up to this line because here is our peak value of voltage. So this is how we have to represent the phasors, or we have to represent the values in phasor diagram. So what is the conclusion from this? The voltage and current, they reach zero, they reach maximum, they reach minimum together, which means there is no phase difference between each other. They are in phase with each other, which means the voltage and current are in phase with each other. So this is all about the basic introduction and the AC parameters and about the condition when the AC voltage is applied to a pure resistive circuit. So in the upcoming sessions, let us learn more conditions by applying the AC voltage to a pure inductive circuit and capacitive circuit and many more. Until then, keep learning. See you all in the next session. Thank you.